let's explore the notion of a polynomial. So this seems like a very complicated word, but if you break it down, it'll start to make sense, especially when we start to see examples of polynomials. So the first part of this word, let me underline it. We have poly. This comes from Greek for many, and you see poly a lot in the English language, referring to the notion of many of something. So in this case, it's many nomials. And nomial comes from the Latin nomen, for name. So you could view this as many names. But in a mathematical context, it's really referring to many terms. And we're going to talk in a little bit about what a term really is. But to get a tangible sense of what are polynomials and what are not polynomials, let me give you some examples. And then we could write some maybe more formal rules for them. So an example of a polynomial could be 10x to the 7th power minus 9x squared plus 15x to the 3rd plus 9. This is a polynomial. Another example of a polynomial, 9a squared minus 5. Even if I just have one number, even if I were to just write the number 6, that can officially be considered a polynomial. If I were to write 7x squared minus 3, let me do it in another variable, 7y squared minus 3y plus pi, that too would be a polynomial. So if these are examples of polynomials, what are examples of things that are not polynomials? Well, if I were to replace the 7th power right over here with the negative 7th power, so if I were to write 10x to the negative 7th power minus 9x squared plus 15x to the 3rd power plus 9, this would not be a polynomial. So I think you might be sensing a rule here for what makes something a polynomial, that you have to have non-negative powers of your variable in each of the terms. And I just use that word term, so let me explain it because it'll help me explain what a polynomial is. A polynomial is something that is made up of a sum of terms. And so, for example, in this first polynomial, the first term is 10x to the 7th. The second term is negative 9x squared. The next term is 15x to the 3rd. And then the last term, maybe you could say the fourth term, is 9. And you can see something, let me underline these. So these are all terms. This is a 4-term polynomial right over here. And you can say, hey, wait, this thing you wrote in red, this also has 4 terms. But we have to put a few more rules for it to officially be a polynomial, especially a polynomial in one variable. Each of those terms are going to be made up of a coefficient. This is the thing that multiplies the variable to some power. So in the first term, the coefficient is 10. And let me write this word down, coefficient. It's another fancy word, but it's just a thing that's multiplied, in this case, times the variable, which is x to the 7th power. So the first coefficient is 10. The next coefficient, and actually let me be careful here, because the second coefficient here is negative 9. So we are looking at coefficients. The third coefficient here is 15. And you can view this fourth term, or this fourth number, as the coefficient, because this could be rewritten as, instead of just writing it as 9, you could write it as 9x to the 0 power. And then it looks a little bit clearer like a coefficient. So in general, a polynomial is the sum of a finite number of terms where each term has a coefficient, which I could represent with the letter a, being multiplied by a variable, being raised to a non-negative integer power. So this right over here is a coefficient. It can be, if we're dealing, well, I don't want to get too technical. It could be a positive, negative number. It could be any real number. We have our variable, and then the exponent here has to be non-negative integer. So here, the reason why what I wrote in red is not a polynomial is because here I have an exponent that is a negative integer. Let's give some other examples of things that are not polynomials. So if I were to change the second one to, instead of 9a squared, if I wrote it as 9a to the 1/2 power minus 5, this is not a polynomial because this exponent right over here, it is no longer an integer. It's 1/2. And this is the same thing as 9 times the square root of a minus 5. This also would not be a polynomial. Or if I were to write 9a to the a power minus 5, also not a polynomial, because here the exponent is a variable. It's not a non-negative integer. So all of these are examples of polynomials. So there's a few more pieces of terminology that are valuable to know. Polynomial is a general term for one of these expressions that has multiple terms, a finite number, so not an infinite number, and each of the terms has this form. But there's more specific terms for when you have only one term, or two terms, or three terms. So when you have one term, it's called a monomial. So this is a monomial. This is an example of a monomial, which we could write as 6x to the 0. But you could also, another example of a monomial might be 10z to the 15th power. That's also a monomial. Your coefficient could be pi. It could be pi. So we could write pi times b to the 5th power. Any of these would be monomials. So what's a binomial? Well, binomial is where you have two terms. Monomial, mono for one term. Binomial is you have two terms. So this right over here is a binomial. Binomial. You have two terms. And all of these are polynomials, but these are subclassifications. So it's binomial, you have 1, 2 terms. Another example of a binomial would be 3y to the 3rd plus 5y. Once again, you have two terms that have this form right over here. Now you'll also hear the term trinomial. Well, trinomial is when you have three terms. Trinomial. And this right over here is an example. This is the first term, this is the second term, and this is the third term. Now, the next word that you will hear often in context with polynomials is the notion of the degree of a polynomial. And you might hear people say, what is the degree of a polynomial? Or what is the degree of a given term of a polynomial? So let's start with the degree of a given term. So let's go to this polynomial over here. We have this first term, 10x to the 7th. The degree is the power that we're raising the variable to. So this is a 7th degree term. The second term is a 2nd degree term. The third term is a 3rd degree term. And you could view this constant term, which is really just 9, you could view that as, sometimes people will say the constant term, sometimes people will say the 0th degree term. Now, if people are talking about the degree of the entire polynomial, they're going to say, well, what is the degree of the highest term? Or what is the term with the highest degree? That degree will be the degree of the entire polynomial. So this first polynomial, this is a 7th degree polynomial. This one right over here is a 2nd degree polynomial because it has a 2nd degree term, and that's the highest degree term. This right over here is a 3rd degree. You could even say 3rd degree binomial because its highest degree term has degree 3. If this said 5y to the 7th instead of 5y, well, then it would be a 7th degree binomial. This right over here is a 15th degree monomial. This is a 2nd degree trinomial. Now, the last thing I will, or a few more things I will introduce you to, is the idea of a leading term and a leading coefficient. So let me write this down. The notion of what it means to be leading. Well, it usually means, it can mean whatever is the first term, or the coefficient. If you're saying leading term, it's the first term. And if you're saying leading coefficient, it's the coefficient in the first term. But it's oftentimes associated with a polynomial being written in standard form. So standard form is where you write the terms in degree order, starting with the highest degree term. So for example, what I have up here, this is not in standard form because I do have the highest degree term first, but then I should go to the next highest, which is the x to the 3rd. But here I wrote x squared next. So this is not standard. If I wanted to write it in standard form, it would be 10x to the 7th power, which is the highest degree term. That's the degree 7. Then 15x to the third, so plus 15x to the third, which is the next highest degree. Then negative 9x squared is the next highest degree term. And then the lowest degree term here is plus 9 or plus 9x to 0. Now this is in standard form. I've written the terms in order of decreasing degree with the highest degree first. And here it's clear that your leading term is 10x to the 7th, because it's the first one. And our leading coefficient here is the number 10. So there was a lot in that video, but hopefully the notion of a polynomial isn't seeming too intimidating at this point. And these are really useful words to be familiar with as you continue on your math journey.